Hi, it's Mr. Anderson, and this is AP Physics Essentials video 114. It's on traveling waves. Traveling waves are waves that move from one point to another. They don't just keep bouncing back and forth. And Jeff Rowley was able to ride this monster wave, and he was able to actually paddle into it. But when you watch surfers like this, you'll see them surfing waves that seem big, but the weather lots of times is really nice. And so the reason why is that these waves came from somewhere else. And so what increases the size of the wave? Well, waves are created by wind blowing over the surface of the ocean. So if you have a fast wind blowing over the surface of the ocean, then you're going to have bigger waves. We also could have the period of time over which that wind is actually blowing. And then we have what's called fetch. Fetch is the area over which the wind is blowing. So if you want to get a monster wave, you have to have high speed for a long period of time over a very large area. That's going to create these traveling waves that move somewhere else. And so waves can be traveling or standing waves. Traveling waves, just like the name implies, move from one area to another. But standing waves appear to, quote unquote, stand still. It doesn't look like they're moving at all. Now they actually are, and what's happening is the traveling waves are bouncing back and forth, and due to interference, they're creating these stand still or standing waves. You should understand how we could get one-dimensional interference between traveling waves and also two-dimensional traveling wave interference. You get what's called a circular wavefront, and then you can get these interference patterns. And so let's look at a traveling wave. This is a PHET simulation. We're creating some waves. In this magical simulation, the waves simply go out the door and they go on forever. And so the traveling waves are created on the left, and then they just keep going and going. But what happens if we have a fixed point on the other side? When the wave gets to the other end, it's actually reflected back, and it's inverted. Now you can see it moving to the left, and then boom, it's going to bounce back to the right. And so these traveling waves are going back and forth and back and forth. And as they do that, they create these standing waves that appear to stand still. You'll have these little nodes and antinodes, but they're made up of traveling waves interfering with each other, bouncing back and forth. Example of that is right here. We've got these blue waves moving to the right. We've got these red waves moving back and forth, and then we have the summation of the two. We have interference, which is creating this big wave, areas where it's not moving much and areas where it's moving quite a bit. And so the reason why is due to constructive and destructive interference. If we have two waves that are stacked right on top of each other, you'll get these monster waves constructively built. And then if they're out of phase with one another, what you'll get is destructive interference, where they're actually canceling each other out. Now, it's not as regular as that. As waves interact, what you'll get are these irregular patterns where we're having constructive and destructive interference. These are actually beats that would be produced by noises or pitches that are a little bit slightly out of frequency. Now let's go to two dimensions. So if we're looking at two dimensions in this simulation, what I've got is water being dropped, which is creating these wave fronts that move out from that dropped water. And we're measuring it in the middle. But what happens if we have two drips of water that are coming down? Now we have two wave fronts. And as those wave fronts interact, what we get is interference. You can see some areas where they're canceling each other out. We have these gray areas where there isn't much waves. And then we have these darker areas. And so let me pause this right here. So what happened is, if we're just measuring it along this length, you've got big waves right at the beginning, large waves, and then it's kind of canceled out. We don't have as big a wave in here, and then those waves return on that side. Example of it, if we look at it in a two-dimensional kind of a simulation, if we're making waves that are the exact same frequency, you'll get these huge areas where the waves simply cancel each other out. It's called an interference pattern. And then we'll have that constructive interference where we get this monstrous waves in the middle. And so did you learn to analyze or evaluate interactions at one dimension, at two dimensions, as waves, traveling waves, interact with each other? I hope so, and I hope that was helpful.